Circuit breaker measures appear to have helped. The number of new cases in the community has decreased from an average of 39 cases per day in the week before to an average of 29 per day in the past week.
Let us just pause down here. So how did Minister Gan came up with the number 39 and 29? Did he just pluck them out of nowhere? But more importantly, is the decrease from 39 to 29 due to circuit breaker, or is it due to random chances? Good evening, this is Mr. Wintermelon. So this will be a two-part video where you will learn a statistical test called the t-test, whereby you will learn how we can use Excel to perform a t-test and decide whether the circuit breaker did make a difference. So the objective of this video is for you to learn how to use Excel to perform t-tests to compare whether two means are significantly different. But some disclaimer first. And because Minister Gan was using week by week, we only have 7-day data point. So it's not exactly good for t-tests. But the focus here is on the skill of using Excel. So let us just ignore whether t-test is actually a suitable statistical test for this scenario. Why I'm choosing t-test is because it's a very basic statistical test and it's very easy to learn how to do it in Excel, and you can use it for a lot of biological study. So the main point is learn how to use Excel to perform t-tests. When, let's say, you encounter data that is more suitable for using t-tests, you will be able to use it. Okay, next thing I want to point out is the definition of p-value is very meh. You will not know what is p-value at the moment, but if you are an expert, you will know what is p-value. So p-value is very meh. While the meaning emphasized in this video is wrong, but it will help a person to come to the same conclusion as someone that is taking p-value as the actual definition. So these are the disclaimer. I know there are things that are wrong down here, but the key thing is focus on how to use t-test. So what is t-test? T-test is a statistical test to help us compare whether there is a significant difference in the mean of two samples. So you see the two words that are highlighted in red, you might not know the meaning. First is mean, then there is significance difference. So what is mean? So mean is actually a form of average. Average, there is three types: mean, mode, and median. So what Minister Gan was saying earlier on is probably referring to the mean, average, rather than mode or median. So the mean down here is the average that you have learned in primary school, which is the number of confirmed cases on Monday plus the number of confirmed cases on Tuesday plus all the way until the number of confirmed cases on Sunday divided by 7, you will get the average mean. So this one is the mean. So t-test will help to compare the mean of two samples to see whether there is significant difference or it happens by random chances. So what do I mean by significant difference? To understand significant difference, we have to talk about two things. The first thing is probability, then the other is normal distribution. So let us talk about probability first. Here you can see the score of Everton against Newcastle. It is 93 minutes and there are 4 minutes of added time. Everton is leading 2-0. What do you think is the final score?
From the right, the central defenders are in there. It's towards the goalkeeper on the 6-yard line. Back across it comes. Overhead kick is in. Newcastle have scored. They get one back. Eyes on the referee. Ritchie towards the right. Defenders in the box. Controlled by Fernandez. Played across. Chance here for Newcastle. And another. And it's saved on the line. Have they got it in? They can't scramble it in. It's gone in. It's an equaliser. The referee has looked at his watch. Technology has given them a second here against Everton. It's definitely a goal, and somehow they have managed to salvage a point. They've got an equaliser.
If your guess is Everton 2 and Newcastle 2, you are correct. But if you are someone that doesn't follow soccer, you would probably not guess that Newcastle is able to equalize. So probability is a way of saying there is chance of things happening. So most of us would think that Everton will win this game. Who would have thought that Newcastle will come back and draw the game? But nevertheless, there is a probability of this happening. So when we are collecting data, there is probability of data collected being not as accurate as we like. There is probability of the data that we have collected not being a good reflection of the whole picture, because we can only collect so many data with our given time. We cannot collect all the sample, because let's say we collect all the sample of the grass, then maybe the gazelle will not have any food to eat. In science, we are only collecting a sample, and there's a probability that it is not a good reflection. So this is an example of probability, and it should let you appreciate that we are living in a probabilistic world. There is no definite when it comes to science. So next, let us talk about normal distribution. Over here, I have a $1 coin. Let's say I flip it 10 times. You will expect the probability to be like this. I want to find out how many heads that I will get. So 0 head, the probability of getting 0 head is probably very low. So you can see on the graph, it is very low. Most likely, if this is a fair coin, I will get 5 heads. So the probability or the chance of me having 5 heads is the highest. And the chance of me getting all 10 heads will also be low, as low as 0 head. Now, if we flip the coin 1000 more times, that means 10 times times 1000 times. So most likely we will get a graph that is similar to the probability graph. The number of times that we get 5 head out of 10 will most likely be the most frequent, and the least frequent will be us getting 0 head as well as 10 heads. So this type of graph, we call it a graph of normal distribution, or a bell-shaped curve. So this bell-shaped curve, it shows that the probability of occurrence in the mean is the highest. Then as we go away from the mean, the frequency will decrease. So this is the normal distribution. Higher frequency will be the mean. Then as the data become more and more extreme, the frequency will decrease. To put it in actual context, so let's say we plant a packet of green bean and let them grow. Then we measure the height of the seedling after 5 days. Most likely I will get a normal distribution, whereby I have some shorter bean and some that are very tall, but generally the frequency or the number of those bean are very little. Most of the bean will be around the height of the mean. Those taller one or shorter one, the frequency will decrease as they get taller or as they get shorter. Next, let's say I want to compare the height of the seedling of green bean with red bean. And this is my red bean seedling result. You can see that generally, red bean is taller than green bean. But there are still some red bean that are shorter than some green bean. So it might not be easy for me to conclude that red bean seedling is taller than the green bean seedling. So the question will be, how much taller will be enough for me to conclude that a bean seedling is taller than the other bean seedling? If let's say I have soya bean and their height is like this, is this enough for me to conclude that the soya bean seedling is taller than the green bean seedling? So now is the time I want to bring in the term confidence level. Now, let me ask you, are you more confident that the red bean seedling is taller than the green bean seedling? Or are you more confident that the soya bean seedling is taller than the green bean seedling? Most likely you will tell me that you are more confident that the soya bean seedling is taller than the green bean seedling, while the red bean seedling, it might just be due to random chance. So in science, we make our conclusion based on this thing called confidence level or confidence interval. So let's say I have a curve down here. There is no overlapping. So your confidence level will be very high, that they are significantly different. What if there are some overlapping? So in science, we do allow overlapping of data, and we can conclude that they are significantly different even though there is overlapping. And the range that we take is normally at least 95%. So I draw two dotted lines. Then within the dotted line, it will encompass 95% of the data. Then on one side, it will be 2.5%, and on the other side, it will be another 2.5% of the data. So if the overlapping is only 2.5%, in science, it is the so-called entry level whereby we conclude two data are significantly different. We are confident enough to say that both data are significantly different if the overlapping is 2.5% or less. That means the confidence interval that we are using is 95%, and because the curve have two sides, the overlapping is 2.5%. 2.5% on one side and 2.5% on the other side. Now, there are cases whereby some scientists might take only one side. It can happen, but it's only in cases whereby you really expect one data to be higher than the other or vice versa. But for a t-test to be stronger, we will take it from two ends or two tails. The 2.5% at the lower extreme and the 2.5% at the higher extreme. Now, if the overlapping is more than 2.5%, then we conclude that the data are not significantly different. Now that you understand what is confidence interval, let us go through this thing called a p-value. It is the same graph, and the p-value, I have shaded it in red. P-value, P here stands for probability. P-value is the probability that mean is actually down here at the red color region at the extreme end. This can actually occur because, like I mentioned earlier, in the Everton and Newcastle example, there's probability of crazy thing that can happen. So let us look at this circle. Now, so assuming that this circle is the entire population and the mean is right in the center. And like I said, most of the time when we collect data, we only collect from a sample. It is possible that the sample that we collect, the mean is actually down here. Another person that is collecting from the same population where the mean is down here. So there is always a possibility that the mean can be at the extreme value. So that is what p-value is actually all about. Therefore, there is the chance that both mean can actually be the same, because the mean can actually be inside the extreme value of both sample, one at the higher extreme and one in the lower extreme. There is probability of this happening, but like I said, this is the actual meaning of p-value, which like I said is very meh and difficult to understand. How I like to explain p-value is like this. Easier way of understanding p-value. So when you are doing science, you might have heard of hypothesis. When we are doing statistics, we also talk about hypothesis. There is null hypothesis where we say that there is no significant difference in two samples. Then there is also alternate hypothesis. There is significant difference between two samples. So when we are doing statistic analysis, we have two hypotheses. One is there is different, the other there is no different. I think this is very easy to understand. So later on, when we are doing our t-test in Excel, you will get a number. The number that Excel gives us is actually the p-value. So how I like to explain p-value is like this. P-value is the probability that the null hypothesis is true. So the p-value that our Excel gives us is there is no significant difference. So if the p-value is low, that means the probability that there is no significant difference is low. Most likely, there is significant difference. So p-value is just an arbitrary percentage for us to reject the null hypothesis. Normally, scientists will use 0.05. That is the standard, but there are also cases whereby the scientists want to be very sure. They will use 0.01 or 0.001. So when the p-value is like 0.001, it tells us that there's 0.1% that the two samples have no significant difference. So when there's 0.1% that the two samples have no significant difference, most likely you will say that there is significant difference. So this is how I like to explain p-value, even though I know it's wrong, but it's easier for us to understand it this way and do statistics. So with this out of the way, let's go through some assumptions that I have made for this analysis. The data I have taken, or the number of daily confirmed cases, are the number that is released from Ministry of Health, rather than the actual number that is confirmed on that day. Because if you look at their annex, you can see that some of them are actually confirmed the previous day, rather than the day they actually announced them. The next assumption, which is a big assumption, is I assume that it takes 2 days for someone to be confirmed diagnosis after they are being hospitalized. So this is actually very important, which I will explain why later on. How do I come up with these 2 days? Now, I actually have a very difficult time deciding how many days to use, because if you read the report, right, the earlier report, let's say for case 103, she went into NCID on 25th of Feb. Then after 6, 7, 8, 9, and 1st, after 5 days, then the result was confirmed. But for case 107, it took only 3 days. There are also other cases whereby for case 201, it takes 8, 9, 10, 11, 12, 13, 6 days for the result to be confirmed. While the next case, 202, it only takes 1 day. So why does different people take different amount of time to be confirmed of whether they have the virus? This is actually a big puzzle for me. If I look at other day, even the later case 1028, report symptoms on 20th March, Then it took 10 or 11 days. On 1st of April, then she's confirmed with the virus. While the case 963, it took 3 days. Then far later, 7 April, 10 April, 3 days. For case 1943, it takes 5 days. So all this difference in number of days gave me a hard time deciding what is the day that I should be using. And it also raises the question, is there a preferential treatment for some patient? But if you ask me, most likely what happened is this. If a person is showing a lot of the symptoms, most likely they will run the test for that patient blood first. Then for someone that is showing maybe 2 out of 5 of the symptoms, the queue will be further down. And for just now, earlier on, 20th March to 1st April, the way they report this might not be very good because they did not state when she was hospitalized. It only state that she report the onset of the symptoms. It might be to her GP. And in other cases whereby it is very long, it might be a few tests was run for the patient. Maybe the first test was negative, then the second was positive. So there's a delay. I actually wanted to find information on this for dates that are in May, but they stopped releasing it after circuit breaker. So I can't really find the data. But what MOH did release were some of the information on healthcare worker, and I generally saw a 1 or 2 days diagnosis period, which is why I assume that as we enter circuit breaker, the average diagnosis time is 2 days. And this diagnosis duration is important. So let's take, for example, if let's say someone is sick on the 16th of April, did the person caught the virus before or during circuit breaker? If the diagnosis period is actually 5 days, which you have saw earlier on, he would have been hospitalized on the 11th. Then there's also one assumption which I did not mention, which is from getting infected to the report of symptoms, I take it as 5 days. This average seems to be quite a reliable number. If you Google it, it will be, and if you go to the MOH website, the mean transmitted date to the report of symptoms is 5 days. So let's say the patient reports symptoms on 11. So let's say the patient reported symptoms on 11. That means the patient had caught the virus 5 days ago. That's the assumption that we are making. So if the patient caught the virus 5 days ago, it will be before circuit breaker, which is 7th of April. That means it is not the circuit breaker fault that he caught the virus, because he caught it before the start of circuit breaker. On the other hand, let's say that the diagnosis actually only take 2 days. So if a patient is confirmed to have the virus on 16, that means he or she would have reported the symptoms on 14. And since we assume that the patient got the virus 5 days ago, it will be on 9th of April. That means the patient caught the virus during circuit breaker. So this is important for us to assess whether circuit breaker did have an impact on reducing the number or not. So now you should be able to see why the diagnosis day is important, because this assumption allows us to assess whether the patient caught the virus during or before circuit breaker. So with that being said, since it takes 2 days for someone to be confirmed diagnosis after hospitalization, a patient that is hospitalized after circuit breaker start, for example, on 7th of April will be reflected on 9th of April. Again, this one is an assumption. So next assumption I have mentioned earlier, it takes 5 days for the symptoms to come out after a patient caught the virus. That means for someone that was hospitalized on the circuit breaker date, which is 7th of April, he or she caught the virus on 2nd of April. And these 5 days and 2 days actually make the analysis easier because 5 plus 2 will be 7. So it will be 7 days. So it is 1 week. So the 1 week thing is actually a small reason why I choose 2 days. The 5 days is a day that is generally agreed by the healthcare community. And like I said, if you go to the MOH website, the mean number of days before the onset of symptoms is actually 5. So this is the implication. Let's say someone caught the virus on circuit breaker day, 7th of April. After 5 days, the symptoms will appear if it is serious enough. So this is the assumption, because there are people who have the virus but is asymptomatic. So when I said 5 days to the onset of symptoms is for those people that show symptoms. For people that does not show symptoms, we actually do not know. After the patient caught the virus on 7, which means circuit breaker day, it takes 5 days for the symptoms to come out. So he or she would have reported to the hospital on 12. Then it takes 2 days for the diagnosis to come out. Then it will be shown on the data released by MOH that he or she is one of the patients that make up the number on 14th of April. So what this means is, for number that are reported from 7th of April to 13th of April, that means this 7-day or 1 week period, they caught the virus before circuit breaker. So if there's no significant difference between the first week of circuit breaker and the previous week, it is because those confirmed cases caught the virus before circuit breaker. For patients that caught the virus during the first week of circuit breaker, their number will be reflected from 14th to the 20th. And for patients that caught it during the second week, their number will only come out on the third week. If we can appreciate this, we can fairly assess whether circuit breaker have a impact on reducing the number of daily cases. And for the last assumption, you should have seen it coming. The week that I am taking is Tuesday to Monday because circuit breaker starts on Tuesday. So it makes sense for me to start the week on Tuesday to see the full impact of the circuit breaker from the number that is released on the second week. So with all this explanation and assumption, click on the next video to learn how to use Excel to perform a t-test to find out whether circuit breaker have a significant effect on reducing the number of communal transmission.